Hey guys, welcome to Great Learning. Google Cloud Platform, or GCP as it's popularly called, is considered to be one of the top cloud computing platforms in the world today. The rise in demand for cloud computing usage has seen Google add a lot of new services and features to its platform. With the steep increase in the usage of GCP, there is a creation of a gap wherein more and more proficient Google Cloud Platform professionals are required every single day across multiple domains. Having a good working knowledge of the platform is a vital requirement here. And keeping this in mind, we here at Great Learning have come up with this Google Cloud Platform tutorial to get you up and running with the platform with an ample number of easy to understand theoretical discussions along with practical demonstrations as well. So with this, what are we waiting for? I know you guys are excited to get started, so roll the intro.
Before we get started, I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, so coming to the agenda of this particular session, Google Cloud Platform tutorial, it becomes super important that you have a complete understanding of the platform, right? But the learning curve of the platform can definitely be steep. That's the reason we have come up with this tutorial where we'll be discussing a lot about the introductory aspect of it theoretically as well as practically, as you can see. Now the first item on the agenda we're going to start out with is the introduction to the Google Cloud Platform. We need to understand what it is, what Google is trying to achieve with their platforms, and a lot more. Once we understand that, you also have to take a look at why Google Cloud Computing Platform is so popular these days, right? Usually the name that gets thrown around is AWS whenever someone talks about cloud computing, but Google is trying to become a huge force in this domain. So we need to understand why. The next thing we're going to take a look at is to understand all the popular clients that we have in terms of even AWS, Azure, and GCP. This way, you'll get an understanding that one client, one person who has a requirement for cloud computing platform can definitely take a look at multiple different providers and then make a choice. And of course, as you'll see in many cases, these guys will also have access to multiple platforms at the same time. Now, once we understand all of that, we also have to take a look at the global infrastructure, as in the infrastructure that governs how the entire world of GCP functions, right? Once we understand that, we'll have a demonstration wherein you'll have an entire walkthrough regarding how the user interface is, how easy it is to navigate around with Google, and of course, Google has a fantastic user interface, and they know how to drive a good user experience. So you're going to see all of that hands-on, and of course, we'll be discussing a small demo on how you guys can set up, storage services with respect to GCP as well, because once you've got that covered, that's going to be a foundation for everything that you're going to build going ahead, right? So I hope you guys are as excited as I am for this one. So without further ado, let's get started. I think it's high time we talk about the newest boy in town, which is Google Cloud Platform, right? Now, I said they are the newest boys in town, even though they launched 2 years earlier than Microsoft Azure. Now, I told you Azure launched in 2010, GCP came out in 2008, but when you look at popularity, when you look at trends, when you look at the actual usage that went into the platform, these guys, in terms of growth, they were a little slow because first of all, these guys are brand new. Google is not a new brand to you, I'm sure, but Google Cloud Platform, to provide these kind of services itself, they were slightly new in this particular domain. To scale up to already existing giants is not an easy thing, right? Now, all of you all who are watching it, in case if you guys want to become entrepreneurs, you want to start your own company, think about Facebook, Google, Twitter being your direct competitor. In that particular case, for you to grow as big as them, It's not an easy task, right? Similar what happened to Google Cloud Platform as well. AWS and Azure were already there, who had the majority of the industry. Everyone trusted them. Everyone started using them. So there weren't a lot of people, first of all, to start using the Google Cloud Platform, because the services that was provided here were in number a little less, and that when someone is accustomed to one particular cloud platform, I'll tell you this from my personal experience, usually they will not want to switch. If you're looking to migrate from AWS to Azure, or if you're looking to like cancel all your subscriptions and all of that, AWS will do everything in their power, and of course all of this is legal and everything, to make sure that you stay on their platform and not leave. They're going to provide you services, they're going to provide you discounts, they're going to do so many things to make sure you don't jump ship and go to someone else. That's not a bad thing, that's actually a great thing. But at the end of the day, if you are a person like the experts at GCP who's looking for more customers, then from your point of view that doesn't look that great, right? So that is one of the reasons I think they slowed down, but then now they're catching up at a pace which is phenomenally fast, which I've never seen before. And the number of job openings, if you look at it on LinkedIn or Indeed.com for experts who are wanted on the Google Cloud Platform, you will realize every single point that I just told you all, right? Perfect. The second point, the most important one in discussion here, the point that I am a huge fan of personally, is that the data centers that Google run for their Google Cloud Platform are environmentally friendly, guys. They all run on 100% renewable energy sources, be it solar power, be it wind energy, be it hydrothermal, whatever it is. So this is telling us that, hey, we can have sustainable ways of running the world of information technology and not have to hurt our planet, right? Because the planet provides, it can be eternal if we take care of it. But then if you go on to misuse a lot of different things that Mother Earth provides, well, at the end of the day, there's going to come a time where the balance is lost and you cannot gain back the things which are once lost. Right now there are so many animals or species that have become extinct when you think about it, right? They're lost forever. Now at the end of the day, for me as a person who values all of these things, and similarly we have hundreds of thousands of people who think like this as well. Now you will look at a trend where people are buying electric vehicles because they don't like the amount of pollution an actual petroleum or a diesel car puts out. Now even these guys have a thought saying, hey, they might be hurting the environment way more than they initially thought they would, and they are jumping ship, right? This happens even in millions of dollars worth of transactions. Even big companies who put them out, who market themselves as a company that says we are environmentally friendly, but then they're running on servers which are not environmental friendly. I'm not saying that AWS is bad, I'm not saying Azure is bad, or that they're polluting the environment, all of those things. But at the end of the day, when you take a look at it, having this kind of a bragging right which says we are using servers which are environmentally friendly, something that's going to market itself for the days to come, right? That's important, guys. The third thing, as I already told you, was AWS has a ton of services. Azure has a ton of services. Guess what? In the next couple of years, even Google Cloud Platform is going to have a ton of services as well. The most popular applications of GCP, in my opinion, again, when I asked a couple of people, when I ran a poll, I asked why, people think Google Cloud Platform is popular, or what are they best known for. 8 out of 10 people always were willing to choose big data services. Now, the big data service that Google provides, and there's multiple things, BigQuery and a lot of other things. So these guys are known really, really well, in fact better than AWS and Azure, to handle that kind of data in a seamless fashion. So that is one of the reasons why, when you take a look at the rapid establishment and the rapid growth, now they're playing the catch-up game in the world of cloud computing. But I have a personal feeling that somewhere down the line, it'll be the others who will play the catch-up game with GCP, right? Perfect, guys. Now to talk about the popularity of GCP really quick. The first point again has to be return on investment, right? What are you getting for the amount that you're spending? Whenever we have championed all of these modules, whenever I say pay as you go, you're paying only for the minute, you're paying only for the hour that you're using the product and all of that, there is a slight catch here. When you go on to use AWS, and some of these services in AWS usually rounds it to the next hour. Now what I mean by that is, if you use a platform for 3 hours 35 minutes or 3 hours 40 minutes, sometimes you're billed for 4 hours. It rounds up to the next hour of usage, right? Now you're paying for 20 minutes that you haven't used. used. But in the case of GCPs, these guys are very efficient in terms of pricing. If you've used it for 3 hours 32 minutes, you're probably billed for 3 hours 32 minutes or 3 hours 33 minutes. So 1 minute extra, it rounds out to the next minute, and that's the ceiling of it. You're not paying for the next 20 minutes as well. Now, in our discussion, for a learner, this will seem like, okay, does it really make that big of a difference? Well, at the end of the day, think about it in the perspective of a company who would probably spend millions of dollars to keep their application running on the cloud, right? They would save thousands, if not hundreds of thousands of dollars with just this 20-minute adjustment or whatever it is. I gave you an example, but when you think about the enterprise level solution that GCP are offering in terms of rounding up to the next minute rather than the next hour, is again attracting a lot of clients to these guys, right? Perfect. Alright guys, checking out the next reason of why GCP has been so popular is that Google as a company themselves has such a strong footing that these guys are foundational to the world of networking. These guys are the only guys in the entire world to have the most amount of fastest connections underground, optic fiber networks, networks which support up to 10 terabits per second of transfer. This is not just in one country, this is across the world. These guys hold the dominion there. They're ranking top in the industry. They have laid out cables under the ocean floor. So they, when they are saying, hey, you know what, we will give you the fastest data transfer speed in the entire world, do you really think that customers would not be interested there? Well, 10 terabits a second is like when you think about it, I am honestly surprised, because at the end of the day, it's really not something easy to provide when you have hundreds of thousands of customers who are looking for the same speed. Now at the end of the day, Google say we can do it, they're doing it. And remember the point where I told you that as the other companies are going to start playing catch up, well, this is the first point for them to actually go on to start catching up with GCP. Perfect. Now, taking a look at the next point, I think it adds a lot of value to understand that in the world of data analytics as well as the world of big data, there's multiple services and innovative tools that these guys are providing, right? The first logo you see is of Google BigQuery. The second logo is is of another service called as Google Cloud Dataflow. Now, both Dataflow and BigQuery are so amazing that if you're a person who's learning big data, or if you're a person who's looking towards data analysis, and if you're doing it on Google Cloud Platform, these will be the first services that you will absolutely fall in love with. That is something, again, I've heard from a lot of people. It is true. I've tried it myself. These are amazingly intuitive services to use. Their user interface is actually good. It is getting way better than what it was. And I think it's Google at the end of the day. Everyone loves the ecosystem, the user interface, the user experience which Google provides for us, right? Perfect. The next point that we have to discuss, again, rounding back to our first point, is what is the amount of return that you're going to get on your investment, ROI, as we call it, right? So when you give your money out to GCP, what is the amount of return that you're getting there, right? In that particular case, when you take a look at one particular type of service that GCP, AWS, and Azure provide, the compute engine or the compute services, their GCP's pricing is so amazing that this is almost somewhere around 50% cheaper than what AWS and Azure are providing, to a good extent. Now, in some cases, this definitely is true. And at the end of the day, if it's 50% cheaper, why would you want to spend 50% more, when you could be spending it less, right? When you think as a company, this is the first thing that you would think about doing as well. And in that particular case, I think catch-up game is on for AWS and Azure in terms of pricing as well. The next thing is, data security, something we really have to talk about. And with Google, they have been in the world of networking. They have been on the internet for 20-25 years right now, and these guys have known how to integrate security into their products for all these years. And since their entire product line requires so much of data security, requires so much of authentications, basically at the end of the day, my point here is that when they have been in an industry where they've been doing this for a really long time, they have the experience to go on to become the professionals in it, right? So in terms of data security trust, I think there's no better way to go other than GCP. Right? Perfect, guys. So again, we checked out the quick introduction to GCP. You guys know what it is, when it is launched, why it is popular. We discussed a lot of these points similar to AWS and Azure as well. Now we are coming to an important part where we are going to discuss all the popular clients that these guys have, right? First of all, if you're thinking about AWS, as I mentioned, thousands and thousands of companies go on to make use of AWS, and these guys try to actually push the platform to its limits. Now you've seen so many people, so many companies who use AWS in a way where they are actually in a position of, they say, hey AWS, we're going to push you with everything we've got, and we hope you can hold it at your end. Be it individuals, be it small companies or big companies alike. If you have thousands, if not hundreds of thousands of businesses doing this day in and day out, AWS has to be they have to be fundamentally strong to handle all of these things, and of course they are. But then, guys, I think the most important way that we can numerically assess the popular clients is not just say, hey, Facebook is the most popular client of AWS. Well, it wouldn't make sense. Why is Facebook the most popular client of AWS, right? That is the reason I thought that it'll add a lot of value to actually show you guys who the top spenders are on AWS. So Netflix is paying $20 million monthly, in American dollars, of course, to AWS because they're using all of their services. Similarly, Twitch is again a popular streaming platform. It is mostly known in the world of gamers. I myself stream on Twitch whenever I play on my PlayStation. So there as well, Twitch people, to host maybe all of their streamers, they are using compute services on AWS. They're providing 16 million monthly. LinkedIn are paying AWS $14 million monthly. Facebook are paying $12 million. BBC, the British broadcasting service, the channel, these guys are also providing $10 million. And this amount that you see is not an amount that these guys are paying to AWS on a yearly basis. This is a monthly basis. So this is the amount of money AWS are making for the services that these guys are providing, right? Now, if you're talking about Azure, similarly, even with Azure, let's look at the top spenders. The first big guy who's spending a lot of money, I think, is Verizon, right? Verizon, or Verizon as it's called, is again a very big network provider in the continental United States. Now, even these guys, there's many providers out there. I think Sprint, Verizon, AT&T, all these guys are big there. So these guys, put a bill get a bill of somewhere around $80 million a month from AWS. Then you have MSI computers. MSI is this beautiful, I think, laptop manufacturers who's very well known in the gaming industry. Then you have LG Electronics, right? So LG is a very big name in home appliances. Then you have Adobe, of course, we all know. Then you have Intel, and if you again look at it, right, so these guys are spending millions and millions of amount to get solutions from Microsoft Azure as well. But the fun part that I want to talk about is in GCP as well. You saw that these companies, right, Twitch, Facebook, and LinkedIn, they were also using AWS, but these guys also use Google Cloud Platform, and they are billing $65 million, $42 million, $41 million. So this is what is happening, this paradigm shift. I'm not saying that they're leaving AWS to come to GCP. They're using the best of both. AWS is providing certain services which they absolutely require. GCP is doing something way better than AWS that these guys are interested in. So that's the reason they say, you know what, why should we not have this guy do one thing, this platform do the other thing? So that's one of the reasons why many companies, it's not just these 5-6 people that you see on your screen right now. It's hundreds of companies who do this. They use multiple platforms to get multiple jobs at the hand done, right? So this is an important point that you guys have to know. And I hope when we took a look at these top spending, this was the best way. I could come up with telling you who these popular clients are, and you would of course know the popularity of it, right? Be it Facebook, LinkedIn, Yahoo, Twitch, and all of these platforms. And now, guys, I think when we're talking about the quick comparison that I have in mind for you guys with AWS, GCP, and Azure, now that you would have got a basic sense of it, I don't think I have to, spend a lot of time to tell you the differences that exist between these. When we go on to check out these platforms individually on a hands-on, level, you will come to know the differences that exist. But for now, to quickly take a look at the number of services that these guys are providing. Now, all of this data is as of March 2021, guys. AWS AWS is providing somewhere around 13 compute services, Azure is providing 9 compute services, while GCP is also providing 9 compute services. So in the terms of just the number of compute services that is being provided, I think AWS has the upper hand because they are providing more services, which means that they have more capability and they can cater to a wider audience base, right? Perfect. In the case of storage services as well, AWS leads because they do provide 7 storage services, Azure provides 6, and GCP provides 4 as well. Now, I'm not saying that either of these are inefficient and all of that. That is out of the talk right now. But just with the number of services, right, the things that you could do with every single number. Now, if AWS is providing one more service which would bring them millions of dollars of revenue each month, why do you think they wouldn't do it, right? That's the reason why these guys keep adding services and services. They know that the world wants it and they are there to provide it. But again, in the case of storage services as well, AWS is leading, right? Then when we talk about a really fun thing which I absolutely love is bringing two domains together. In this case, it's artificial intelligence or machine learning solutions, development, deployment of these solutions. Here again, AWS takes a slight edge with the number of services at least, right? AWS provides this really fantastic service called AWS SageMaker for working with machine learning solutions, right? So here they provide 12 AI ML solutions, that is AWS. Azure provides somewhere around 3 services, but then Azure ML is actually very, very, very well established, very popular amongst a lot of people. And then GCP in fact have beaten Azure to this particular service in this domain, and there's a good chance they might overtake AWS as well because they are getting very close to AWS with 7 services now. AWS provides 12, GCP provides 7, Azure provides 3. Right? Perfect. Next, when we talk about database services, there is no other comparison we have to champion about Azure here. Right now, Azure leads this particular service domain with 9 services. AWS provides only 7, while GCP provide only 5 services. Now again, we can talk about each of these services to greater extent, but for your learning path right now, I do believe that if you know these numbers, it is more than enough to go ahead. Right, guys? So this is database services. The next thing which is very, very important that you guys have to understand is server locations. AWS here is again a little bit more popular because they're catering to 24 geographic locations and they have 77 availability zones. Now, when you quickly go on to the AWS site to check about where they're available and all of that, you will be presented with a beautiful looking graph that will show you what are the regions that are catering for. Similarly, Azure, has their footprint in 65 plus regions across the globe, and GCP is showing immense amount of growth. In this particular case, they are present in 22 regions, and of course, they are looking at expanding rapidly from their existing 62 zones as well. So, at the end of the day, when you're comparing Azure, AWS, and GCP, for me, the first thing, I am a guy who's driven by data, and for me, I think all of these data that I just showed you should give you an important idea about what the industry is requiring right now and what these guys are providing. Because see, if AWS comes up with one more service, that is going to create hundreds of thousands of jobs because people are required to be experts there to solve people's problems using that service, right? You have to be trained to use that service. So these creation of jobs, every time there is a new service that comes up, be it in GCP, Azure, or AWS, I am really happy because it creates hundreds, if not thousands of jobs for that particular service as well, guys. So guys, with this, we have come to the end of this particular module. We took a lot of, introductions to all these different domains. We understood about AWS, we understood about Azure, GCP, we found out when they were launched, why they are popular, what are their most popular use cases, and we saw the most popular clients out there, and we also took a look at a quick comparison powered by data, powered by numerical digits of, why these guys have been popular as well, right? So with this particular module, my aim was to provide you guys with this fundamental knowledge that you have to have about these 3 big guys, because I'll be very honest with you, if you're a person who's looking for a job in this industry, there's a good chance when you start out, it'll be either be in AWS, Azure, or GCP. So I thought it'll add a lot of value to your learning that we check this out now. Alright guys, so to move on, the next thing that we're going to take a look at is the GCP global infrastructure, right? Now their servers, the way they operate has been divided into multiple availability zones, regions, and of course a lot more, right? So let's check it out.
when you talk about GCP or talk about any cloud platform, right, how it operates is, what it does is it strategically puts its data centers in different parts of the world. To give you an example, let's assume that you are based in maybe South Africa. Okay, so it would be wise if there's a data center in South Africa which is close to you, right? So people in South Africa can have access to those resources easily, right? What this means is you can keep your business close to you, and if your audience is in South Africa, in that case, these people, when they're accessing your data, the latency would be lesser for them. So that is why it is important to make sure that the data centers are located in different parts of the world. Now the image that you see on the screen is not correct. This is a wrong image that we've put forth here. That was an accident that happened, so you may ignore that, but do not worry, we'll discuss these pointers in detail and I'll give you an idea so you won't miss out on anything. Okay, so do not refer that image that I just removed. Okay, so when you talk about GCP regions, so regions are nothing but these are strategic locations where GCP or Google Cloud Platform plans to put their resources, their data centers. Okay, so when you put forth these data centers in different parts of the world, you are basically ensuring that your data is available across the globe, and people find it easier to use your platform. To give you another example, let's assume that there are 2 data centers maybe in America. Okay, so what people can do is they can actually go ahead and back up their data in different regions. This is where availability comes into picture. Now you might ask, what is availability, Vishal? So availability is nothing, it is the process where you ensure that your data is always available. To give you an example, let's assume that we have Netflix, right? Netflix resides on Amazon Web Services cloud platform. Now Netflix is something that has gained momentum in recent times due to Corona, obviously. So all of us are using Netflix, we are streaming Netflix, and the data is always available. If you have internet, you can always watch movies from there. How does this streaming happen so smoothly? The point to note here is the data is always available. Why? Because it is backed up in different regions. So if one of the data centers goes down, you would always have a copy somewhere that is there, which you can just start switching to and start operating from there. So as a user, you won't be having any downtime, right? These platforms are highly available. They hardly go down like 20 minutes in a complete year's time, and that too won't be noticeable for you. If that happens, I'm telling you, it might not happen as well. Okay, so if it goes down, it might go down for like 20 minutes to the max throughout the year. So that is what tells you how available these resources are. So in case if there's a calamity as well, you can always back up your data. Let's assume that you are residing in a region which is maybe volcano prone, earthquake prone, right? And you're forced to put your data there for some reason, so you can always back up your data somewhere else. So somewhere around maybe 200 kilometers from there or some other place, because these data centers are located at a strategic position. They are put forth at a distance like 60 kilometers or 100 kilometers, 150 kilometers, 200 kilometers, so that if one of the region gets affected, the others would still be safe. Okay, so even if you are in a region that is prone to these natural calamities, if you back it up somewhere, if this region goes down, you can always switch to the other region. That is what availability means. I hope I've answered that point for you people. And disaster recovery has also been explained here. If there's a disaster, you have a backup somewhere, you can recover your data right away. So that is what regions are all about. Okay, and then the next point is your zones. So guys, understand one thing: the geographical region where you plan to put your data, it is called as a region. Suppose if GCP has region in N country, so or data center in N country, so the region where the data center lies is called as GCP region for strategical or logical regioning. Okay, so when you say a GCP region, it is nothing but a geographical location where the data center lies, and the place where the data center lies or the data center itself is called as an availability zone or a zone. That means let's assume that a particular region has 2 data centers. You would say that this particular region has 2 GCP zones. Now these zones are connected by low latency network. So if there are 2 regions in one particular, if there are 2 zones or availability zones or data centers in a particular region. Let's assume that we have a region called as X. In that X region, we have 2 zones. Now these 2 zones inside the region are connected by low latency network, ensuring there is a fast transfer of data between these 2 zones. You can also connect to zones that are located in other regions by using something called as a local zone. Okay, so this is how the global infrastructure of GCP looks like. I'm sorry you cannot see it on the screen because there was a wrong image there, but this is how it is. And the other important point that you need to note here is when you talk about GCP is it has like 61 zones across the globe, and it serves in 35 logical regions across the globe.
Alright guys, now that we have a basic understanding of the infrastructure, I think it's high time we go on to take a practical approach. So we're going to take a quick walkthrough to understand what the GCP user interface is like.
So let's just go ahead and take a look at the demo part, okay? And we'll see what we can do with Google Cloud Platform. See, let me first introduce you to the platform that Google has to offer to us, okay? So in Google, what you do is you first have to create a project. So let's assume that you want to set up certain resources here. You would have to put that under some umbrella, okay? Let's call it, say, project X. So when you create a project X, under that you can set up your instances, you can set up your resources and do quite a few other things, okay? So that is one thing that we can do with it, okay? And what are the things that are there on a plate? You see there's one project that is already there with me. We call it my first project. This was created by default when I signed up for this account yesterday, okay? And there are other things here. The interface with AWS and Azure is little different. Let me show you that as well so that we can compare them face to face, right? AWS management console. Let me see how the management consoles for AWS looks like so that you can compare it, right? I mentioned the fact that AWS console or AWS is smoother to use. The reason I said that was because of the interface as well. You see the interface for AWS is way cleaner compared it with Azure and GCP, okay? So let me quickly sign into it and let me show you how the interface looks like, okay? Now here with GCP, you see we have all this information on the dashboard, and if I have to look through the services, I have to come here. I can either pin these services to the dashboard for easy access, but in order to look at the services, see, I have to scroll down like this, right? I have to look for those particular tools and look what services are there on the plate. Amazon Web Services is easier, right? You just click on services and everything gets organized here. You can even decide how to group it, these services, how to put forth these services under one channel, okay? You can even search for a particular service if you know its name. So I search for S3, you see it gets shown here right away. And just like I showed that you have option of pinning it to dashboard here too you can pin your services. You click on it and say you pick up a particular service. Since we talked about S3, let me pin S3 only. Okay, I just pick it and drop it here, and there you go, my S3 service is pinned, right? I can use it from here. Let's assume that I want to unpin this service. I don't need it here. I just put it back, and there you go, it has been unpinned. So this is where the interface is smoother and easier to use, is what I feel when you talk about Amazon Web Services. But that could be a personal call because I've been using Amazon Web Services for a longer while. GCP, this is how it looks. Let's continue with the discussion part. I'm gonna actually go ahead and launch instances for you, and I'm gonna do it in GCP as well, and I'm gonna do it in AWS as well, just to show you how the instance launching process works in both the platforms, okay? So to do that, here basically what you do is you click on services. If you do not have a project, you'll have to create one. And what is the service we are looking for? We are trying to launch a virtual machine or an instance here. So that is your compute engine, and I'll say VM instances, okay? I'll click on here, and if I say I want to launch an instance, I would have to say create, okay? So let's try and do it with Amazon Web Services as well parallelly. Here we have a service called as EC2, okay? And in EC2 we basically say launch instance here. All the data would be here. You see EC2 directly gives you an option of choosing what instance you want to launch. So let's say I want to launch a Windows server. This is free tier eligible. That means I won't be charged here. So I say select, and I can check for the configuration. What is the network I want to put under it? What is the storage I want to attach to it? Security groups, right? And if not, I can just say launch. you just have to create a key here to log into your instance. Call it say sample key. Okay, and I just download the key pair. You need the key pair, so always ensure you have your key pair up and ready for you, and say launch the instance. Okay, there you go. So instance is launched in AWS. Here it takes a little longer compared to it. You see, you say instance 1, what is the region you want, so you'll be filling in this data here as well. Okay, and then you'd say just go ahead and create my instance. You see, it would create my instance here as well. Once the instance is created, you see there are status checks happening here as well. The instance is getting created, right? Okay, I accidentally launched a Linux instance here. To connect to a Linux instance, we need a key generator, something that we won't be able to do right now. I'll show you this instance here, the ones that is being launched here. So it should look similar if you launch a Windows instance here. Okay, all you have to do is wait for the status checks to happen, and once that happens, we can launch these instances. Okay, let me go back and show you something else. With AWS, you have a service called as S3. Okay, when you talk about Google Cloud, you have something called as Google Storage with you. Okay, where is the storage part? Okay, I'm in Compute Engine, that is why I cannot see it. So here should be Google Storage somewhere that we can work with. Storage, I click Google Storage. There you go. And see, S3 is an object storage. Now Google Storage also lets you create buckets where you can store objects. So I say create a bucket. Again, the name for these kind of storages are always unique globally. You cannot use same name again. Okay, let's call it bucket 54321 and say continue, and then you say you can select whether it should be multi-region accessible or only in one region. So I say one region and I say create. Okay, similarly with S3, you can actually go ahead and say create a bucket here. Okay, give a unique name, let's call it bucket 54321 and I say create. Okay, the name already exists, so let's say 123. Okay, and just like that my bucket would be created. Okay, this is the bucket that I've just created. Here I can put forth my objects, upload my objects. I say upload a particular file. Let's try and do that. Let's upload any file that is there with us. Let's pick this image and put it here, and just like that my upload part is done. Okay, you see within a second my file would be uploaded here. You can add replication policies, versioning policies to these files. Same is with Google Cloud as well. Okay, now we've created a bucket here. I open the bucket. Okay, you don't have to, you can just upload a folder of file here. You say upload file and I select an image here. Okay, and there you go, just like that within a minute here to the file would be added. You see retentions, life cycles. I mean, you can add life cycle management policies. That means you can expire a particular object after a duration if you feel that you are not going to use it and you might forget it. Suppose you are using a particular file for like 15 days and after that you don't want to use it, but you are in a situation where you might forget. So after 15 days you can set a life cycle expiration policy where you can delete these files from here. So that is what life cycle means. You can set up a life cycle for the objects for the files you store. Same is with AWS as well. You can do all these things here. We've launched an instance here, right? So let's just, or created one, so we just need to launch it. So I'm gonna show you how to do that as well. So let me download the remote desktop process file here. Okay, this is something that lets you connect to your instance. Okay, here, and okay, it will ask me for the password first. So for that I'll have to get the password. We had taken up our sample key file, right? So I'll have to choose that file, my sample key file. This is the one, right? And I decrypt it. So this is the password that lets me log into my console. Please note guys that when you talk about AWS, it gives you a key pair. A private key is given to you, public key is with AWS. When you combine them, you can log in. So I'm entering my private key here and I'm saying login, and just like that my instance would be up and running. You see, it took us like a couple of minutes, and within a couple of minutes, even before we created a bucket and put some data there, we had a virtual machine on our disposal, a Windows virtual machine. And if we were to do this using something like VMware, I'm sure there would be a longer time duration that you'd invest in doing that, isn't it? So this is how cloud solves quite a few problems. You can see in this instance as well, there are a lot of things that you can do. It just works like a Windows machine here on your system, which is a separate machine. You see, I can open it, I can close it, and there are other things that I want you to see. Okay, so for every machine that you create, there's some storage that comes attached with it. Okay, and that is the case in case of compute services as well. So since we are talking about VMs here, let me come here and go here. Okay, GCP takes longer to load for some reason. You see, it will give you all the details. Where is this located, right? What are the recommendations that are there? Okay, so you can start, stop, close these instances as you want. All of these instances come with a separate external IP, and they have a storage that comes attached to it, and you can even actually go ahead and add more storages to these instances. Okay.
Alright guys, so now that we took a look at the interface aspect of things, and now let us take a look at a small amount of theory in terms of Google Cloud Storage. This is very, very important for all of you all going ahead. So we're going to get started with some theory, and later we're going to take a look at the practical aspects of it.
Now let us go ahead and understand Google Cloud Storage, what it is and what all can we do with it. Okay. What is Google Cloud Storage? Now there's not a lot of text here. The reason for that is I don't feel that we need to discuss this a lot. We've already understood what cloud storage is, and when we talk about Google Cloud Storage in specific or in particular, so we are talking about a similar storage which is restful in nature, and basically it lets you manage a storage on top of Google Cloud. Okay, so Google Cloud has its own infrastructure, and you are talking about data again that which comes in different forms. It can be your file store, your object store, your multimedia data, your structured data, right? And basically you do a number of things with it, right? It can be your hot storage, it can be your cold storage, something that we'll discuss as we get into the demo part, the hot storage and cold storage part. Okay, so it can be that kind of a storage, right? So these kind of storages are all supported by a Google Cloud, and there are different services provisions that let you store this kind of data. If you talk about its features, right, one of the features is I think we have these features in the next slide. Let me see if there are some. Yeah, there are quite a few features here, and unfortunately the presentation work today done by me is not very good. I've made some mistakes. There was a mistake at the first slide as well, and there's a mistake here as well. I've written strongly consistent twice, so you might just go ahead and ignore the mishap that I've done. So these are some of the features, but apart from that there are other features as well. Like when you talk about it from a latency perspective, that is the delay in which you request a data and the time it reaches you, right? When you talk about Google Cloud Platform, it gives you data at a latency of less than 10 milliseconds. I'm sure none of us can even count 10 milliseconds, right? So that is the lesser amount of time it takes to actually go ahead and deliver the data to you. Apart from that, Google claims that its data is infinitely scalable. That means there's no upper limit to which you want to scale to, and they cannot support that. That is what it means literally. But again, I'm sure everything has a limit. But what they're trying to put forth is the amount of data this world has, they can handle any amount of data is what they're trying to say. So that is one of the features it offers, right? Again, what are the kind of storage services it offers, that we'll discuss at length as we move further. These are some of the features it offers. Single API for all storage classes. So when you talk about an interface, right, application programming interface or protocol interfaces, these are something that let you communicate with your data, with your applications, right? So with a single API, you can communicate with different storage classes in hand. The next thing is it's highly durable. It says 11 nines, right? So that is 99 point what? 9 times 9? That is something like that. So it is that durable, that available as well. That means, to give you an example, let's assume that your data center is available 24/7. In a year, if this data center goes down, which happens rarely, but even if it does, to the max it will go down for like 20 minutes. So that is what 99.9 times durability means. Okay, so highly scalable, high performance. I've talked that Google claims that it can scale as high as you want, right? Performance, again, we've talked about the 10 millisecond thing. And strongly consistent. Now, what do you mean by strongly consistent? So when we say strongly consistent data, right, let's take this to the database part, right? So if you talk about a database, not every database is designed similarly. So when you look at it from a developer's perspective, when you try to put forth some amount of data on any particular resource, right, or on a particular database, now the schema for that database would be different from other databases, and this is highly likely to happen. Now in that case, when you try to move your data, when you try to transact data across different databases, a developer might face a lot of problems if the schemas are different. What Google Cloud Platform does is it gives you consistency when having these schemas in place, these databases in place, so that as a developer, your read writes, your transactions are highly consistent. Okay, so these are some of the features that Google Cloud Store offers. Let's just go ahead and understand what are the different storages or services that it offers. So guys, we'll divide this discussion in 2 pointers. One, we'll understand the different types of stores or storages it offers, and then we'll discuss the different types of databases it offers, because it is little critical when we talk about cloud storages to understand databases as well. Google Cloud Storage services that are there on a plate, right? First one is your cloud storage, which lets you store data in the form of blobs, objects, and files. Not files, objects and blobs basically. Okay, if you're talking about file systems, you have a file store which stores data in form of file systems. Okay, so when you talk about cloud storage that we have on a screen, right, it lets you store data in the form of objects as well. It can be your images, right? It can be your videos and stuff like that, right? So we'll see how this works in the demo part. Then you have your persistent disks. Does anyone know the difference between what a persistent storage is and an ephemeral storage is? Please try answering this question without googling it. That would be really nice. Okay, so just tell me what a persistent storage is to start with. We'll discuss this at stretch, how it is different when you talk about it from a cloud perspective. Okay, so let your answers come in meanwhile. Cloud storage for Firebase. So Firebase, again, this is a little tricky to understand to start with. Basically, we are talking about data that is getting stored. Okay, it can be your objects as well. And when you say a Firebase, there's a different layer of security that we add to our Firebase to ensure that our data is secure there. So that is what this particular service lets you do. Okay, then you have your data transfer services. Now guys, when we talk about data, one, your data moves from one resource to the other. It can move from one class to the other as well, or in many cases it can move from one application to the other, and in worst case from an on-premise resource to your cloud platform. You see, so your data can transfer from anywhere to anywhere, and this happens vice versa as well. Okay, so to transfer this data, we need certain set of services. So what data transfer services does is they let you transfer data, one over the network, another one physically. Okay, so that is what your data transfer services let you do. So we've discussed these things in a nutshell. So when you talk about persistent data store, we are talking about that data store, okay, which again is something that we can actually go ahead and keep hold of even when the connecting device is not there. First of all, to understand this point, I'll have to make sense of what am I talking about the connecting device when I say a connecting device. Okay, so basically when you talk about virtual machines or instances or anything that we launch on our cloud platform that has a storage attached to it. Now for this storage to survive or this storage to operate, we always need this virtual machine. Just like in a laptop, right? We have hard drives. So even though your hard drive can hold like TBs of data, right? GBs of data, but in order to take a look at that data, you need some machine on which you can see that data, right? Say for example, if I have images in my hard drive, unless and until I connect it to a laptop, I cannot see those images, right? So I need my laptop functioning for that. So this kind of storage is something that is dependent on your virtual machines, on your systems to have an access to that data. Now, when you talk about this data source, maybe your hard drive or in this case your disks. So there are two types of it. Okay. So this kind of storage falls under two brackets. One is your ephemeral storage, something that dies when your instance or system dies, and the other one is your persistent storage. You can create this separately and then attach it to your system. So in order to access this storage, you will be needing a system, but even if the system is dead, the storage would be there somewhere. You can connect it to other system and access it, just like our hard drive. So this is what a persistent storage is all about. Let's now go ahead and talk about the databases part, right? So I believe the storage part is clear to you, what cloud storage is, what persistent storage is, how file stores work, how Google Cloud Storage for Firebase works, and what data transfer services are. Let's now go ahead and talk about some other pointers, right? Let's try and understand what Bigtable is, what Cloud SQL is, what Cloud Spanner is, what Cloud Data Store is. Now, as I've mentioned, these are your data stores, database stores to be frank. So this is where your structured data lies in. So when you talk about Bigtable, it handles data that is SQL in nature, that is structured in nature, and no SQL in nature, that is not only structured. That means it can be semi-structured as well. So since we are talking about big data evolution, big data world, we are dealing with data that may not always be very structured. It would be structured in some forms. You'll have your key value pairs and stuff like that, but it won't be very structured. So that is something we call it as semi-structured data. So when you talk about semi-structured data these days, the amount of data that we generate is mostly semi-structured because we are generating data in heaps and bounces. So that is where your Bigtable, your Cloud Spanner comes into picture, okay? And not Cloud Spanner, sorry, your Cloud Data Store. So your Bigtable and Cloud Data Store basically lets you store your data, right, in SQL and NoSQL manner as well. Bigtable in specific is more useful when you talk about dealing with data that is for analytics purposes, whereas when you talk about Cloud Data Store, it can let you store data that deals with applications, mobile applications and stuff like that, okay? Now apart from that, we have other storages that focus on your SQL kind of data, right? So you have your Cloud SQL. This is mostly used to deal with your relational databases, okay? So whatever relational database requirements that you have, that can be handled by your Cloud SQL database. And then you have your Cloud Spanner, which basically lets you hold data, again, which is SQL in nature, but it gives you more availability and more scalability when you compare it with your Cloud SQL. So guys, this was about the theory part. Since we've lost some important minutes in the discussion, or sorry, in the power cut, right? So let's just go back and take a look at the demo. Let's see how cloud storage works on top of Google Cloud. Okay, so let's just go ahead and switch into the Google Cloud Console.
Alright guys, so this is going to be the last demo. Here we're going to be taking a look at Google Cloud Services to a good amount of detail, right? So let's begin.
Okay, so guys, let's just go ahead and take a look at the demo part. And see what we can do with our cloud storage. Okay. For that, I'm gonna sign up into my console. I'm gonna just look for GCP to go ahead with. To be very honest with you guys, I use GCP lesser compared to the other platforms. I've been more adept in using AWS and Azure, or more familiar in using those because I've spent a lot of time working on those platforms. Google Cloud Platform is fairly new for me, but it is something that gives me a lot of pleasure when I work with Google Cloud Platform, because this is also called as the new baby of this cloud computing world, and there's so many things that you can do with it. Okay, so let's just go ahead and see how storages work here, right? So if I scroll down, I'll be having my storage options with me. Okay, you see, you have a Bigtable, you have a data store. In data store, you have options of entities, dashboards, indexes, and getting in all these things. You have your file store here, so you can store your data or your file systems here, okay, in your file system here, sorry, not in Firestore. Okay, and then you have your storage. So if you click on storage, you'll see that, okay, you have option of storing these kinds of data here. I've mentioned, right, when you talk about a cloud storage, you can store data in different forms, different ways. So that is what a cloud storage lets you do. So let's just go ahead and click on browser data, right? So you see there's a bucket that has been created already. I'm gonna delete this. Because it has been active for a fairly long time and I don't want to incur any charges here. So guys, this is a free tier account that I'm using. That means there are quite a few resources that are made available to me free of cost. So you would want to create a free tier account if you're interested in these things, and you can avail benefits of doing that. So let's just go ahead and take a look at the process of creating a bucket here. So guys, when you talk about a bucket, we are talking about a folder in which we can store our data, right? So this kind of a storage is called as bucket object kind of a storage. So whatever file we store, it is in the form of objects that we are storing here. Okay, so let's just go ahead and create a bucket. Let's call it demo for today. Guys, note one thing, these names are unique. So if you like, just go ahead and write a name, say Vishal's bucket, there's a high probability that somebody's already taken that name, because these names are unique globally. So be careful when you choose your names. Okay, so there's nothing about being careful. It's just that you won't be allowed to create a bucket if the name already exists, or a similar bucket with same name already exists. Okay, tips: don't include sensitive information. That is fine, we are not doing that. Okay, what is the next step? Select the type of location that you want your data to be stored. Now guys, see, this is an important information. See, as you go down the ladder, you'll be charged more, okay, if you are using a paid account. Okay, so when you create a bucket, do you want to store data in the same region? If you do that, you'll have low latency. Why? Because what your data transfer is happening, whatever data is there, is there in one bucket only. The thing is, here it is little less when you talk about security part. Why is that? Now, when you talk about it from a security perspective, right, we are talking about our data not being backed up. We have a copy of it in one region only. When you say dual region, basically it replicates your data in two regions, giving you more availability and low latency in some cases. Okay, multi-region, here your latency is less from one perspective. If you have your data backed up in different regions, and if somebody is trying to access that data from a region which is close to that particular backed up bucket, then the latency would be low. Why? Because that person would be able to access your data quickly and at a better pace, right? So that is what a multi-region does. Also, it gives you more availability. If one of the data center goes down, a backup is there in the other region, right? So you can do that as well. By default, it says multi-region, but let's have it for a single region only. We are not working on applications that need you to operate from different regions. US East 1 South Carolina is the data center, or the location of the data center where my data resides. So I say continue. Okay, what kind of storage do I want, guys? I told you about cold storage, hot storage, and different kinds of storages that we have on our plate, right? So what exactly is a cold storage, right? What can you do with a cold storage? Let's try and understand that to start with. So when you say a cold storage, right, basically we are talking about archival storage. Now what that is, I'll come to that in a minute. Okay, so first let's try and understand how data is stored here in a normal storage. So this is a normal storage is more costly for you. Why? Because you put your data there and you can access your data from there right away. You put an image, you can go ahead and take that image out right away. Okay, now when you talk about the other storages you see here, then there's a nearline storage. Now these start falling under your archival storage. What is an archival storage or a cold storage? We are talking about that data where you put your data but you cannot access it right away. Retrieval time for that data is more. Now this data sources are cheaper. Now the reason the retrieval time here is more is because archival storages are meant for storing data that you might not access frequently. This is something that helps you do cost cutting. Now, when you talk about an organization, 50% maybe its data is something that is used every day, and there's other 50% that you use in like months or maybe in years. So why pay a lot of money for using that data? Instead, we can store that in a storage where we are getting charged lesser. And the reason we get charged lesser here is because if you put that data here in that particular resource, you won't be able to access it right away. It will take time for you to access that data, and that is what your archival data is all about, or archival storage is all about. You see, in nearline, if you store your data, it cannot be accessed, or it can be accessed once a month. Okay, if you talk about cold line, you can access this data in less than a quarter. And if you have data that you don't want to use for a year, you can put it in archival. It is the cheapest of all, where you can access this data once in a year, and for the data retrieval these resources charge you. Okay, now let's go ahead and say continue. How do you want to access your data? Whether it should be fine-grained or whether it should be uniform. It says that specific access to individual objects by using object level permission, in addition to your buckets, that is by using IAM, which is a way to access your data. Uniform, ensure that access to all the buckets by using bucket level permissions. So when you say fine-grained, you can define your access to an individual object, right? How do you want to access that object? Who all gets to access that object? When you talk about uniform, all the objects in the bucket are getting accessed in the same manner. Okay, so you can have it uniform. That should not be a problem. Let's say continue, and the final bit is your retention policies. Whether you want to use a Google managed key, a customer managed key, or do you want to add any retention policies to ensure that you can retain this data after a duration. Okay, so let's just go ahead and say create. And just like that, guys, within a minute your bucket was created. I was explaining it, so it took a longer while, else you could have done it faster. Okay, so you see, guys, if I click on buckets, my bucket would be here. So if I open this bucket, I can upload files in this bucket. So let's say whether I want to upload a file, folder, do I want to create a new folder? So I can just pick up a folder and upload it. If I want, I can just upload a file, or I can create a new folder and then upload files in it. Let's say upload a file. Let's just upload this image. There you go. And see, within few seconds, you'll be having your file uploaded here. And all the information related to your file would be somewhere here, right? Is there any retention expiration date? So when you say retention or expiration date, do you want to retain that data? Or in some cases, what you can also do is, let's assume that you want to use this data only for maybe 10 days. So you can set up a retention policy like 15 days and say that after 15 days, just expire this data, just get rid of this data, because you are sure that you're not going to use it after that, right? Accordingly, you can set retention policies as well. Is the bucket public? No, it's not public right now, but I can change the accesses if I want to for my bucket. Okay, if I come here and I say, see, you can edit your metadata as well if you want to. Okay, this is a problem here. These are the things that has happened here. I've created a bucket with different policy, that is why I cannot. Else you get an option here, right, where you can actually go ahead and decide who gets to access what, who gets to delete what, and who gets to work on what. So just go ahead and create one more bucket if you require. Just stick to the basic policies that you have on your plate, and I'm sure that it should not be a problem for you. So let's just say create a bucket again. I'm gonna just call it demo bucket. Okay, so I'm gonna stick to all the basic policies that we have. Okay, and I'm then just gonna go ahead and say create my bucket. So if we create a new bucket and just upload a file here, not a folder, just upload a file. Within a minute you'll be having a file here, right? You see edit permissions. You can decide who the user is, what the name is, and what kind of access do they have. Is it a reader access? Is it a owner access? You can edit these things here depending upon your needs. You can add new users and you can add new rules for them as well, just like that. And then you can control all these accesses the way you want to. So I hope these pointers are making sense to you people, and you've understood what are pointers that I'm trying to put forth here. Okay.
Alright guys, now to summarize everything we have learned on this Google Cloud platform tutorial, we started out by taking a look at understanding what the platform is, why we have Google Cloud Computing Platform, and we took an introduction to understand how it works, what is Google trying to achieve, who is their audience, and a lot more about that, right? Once we cleared with the introduction, we understood why GCP is growing to be a fantastic force among all the other cloud computing platforms that we have today. Once we took a look at that, we also made sure to take a look at all the popular clients for AWS, Azure, and GCP, right? Now you would have a complete understanding of how a client approaches a cloud computing platform, and you'll realize that one client can have access to more than one cloud computing platform. They can interlink it and eventually increase their functionality exponentially, right? That I hope is clear for all of you all. Now, after we understood that, we also made sure to take a look at the GCP global infrastructure, as in to understand how GCP itself works and what governs its functionalities as well. I hope we're clear with that. And once we took a look at that, we made sure to take a look at the demonstration wherein we had a walkthrough to understand the user interface of the Google Cloud Platform. We took a look at various services, various functionalities, and of course we had to discuss a little bit about one of these concepts called as the storage services, wherein we took a look at it theoretically, and of course we made sure to implement a bit of it practically to set the foundation for all of you all to eventually build upon that, right? So I hope everything that we've covered on the agenda in this particular tutorial was clear to all of you all. On that note, thank you so much for watching. My name is Anirudh Rao, and I'll see you on the next one.
I want to introduce you to Great Learning Academy. This is a free initiative by Great Learning where you can have access to over 200 plus courses with 1000 plus hours of free content on all of the trending high demand domains absolutely free. Register now to complete the course and get your free certificate of completion as well. Check out the link in the description box of the video below for more details. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.